Alright, we're going to do a few problems for a little warm up here. See if you can find out what the limit as h goes to 0 of this is. I'll give you a couple minutes. Alright, so if I expand the x plus y squared, we get this. Now what should I do? Good. Combine like terms. I got an x squared, negative x squared. So I'm at 2hx plus h squared over h. Is there anything else I can do here? Should I plug 0 in? What do I get? 0 over 0. So that's indeterminate. We need to do something else. Divide by h. So you're saying factor out an h. And then these h's divide off, so I get 2x plus. Now what do I do? Good. H goes to 0, so I get 2x. That is the correct answer. 2x. Anybody get that?
I got half of that.
We got half of it? You got 4x? Or you got 1x?
No, I got half the process.
Oh, okay. Alright, we'll try another one. I will call it number 2. Alright, so cleaning this up, distribute the 3x squared plus 6hx plus 3h squared minus 3x squared. Finding the limit as x, oh, this should be h goes to 0. So you might have been right because I wrote it down wrong. Why would you think that this is an x? It's clearly an h right there. Alright, so I've got 3x squared minus 3x squared, so they're gone. I can factor out an h on the top. I have 6x plus 3h over h. Those cross off, so I get 6x plus 3h. And while x was going to 0 before, you were right in saying that it was 3h. I just wrote it down wrong. H is going to 0, so we get 6x. Alright, so similar to the first one, it's another parabola kind of thing with a quadratic equation. I'm going to mix it up a little bit here. There is a reason I'm doing all these. We're leading up to a little bit new material on 12.2. Still dealing with limits. Let's do... So remember, this is number 3. Direct substitution, we should try it. If I plug 0 in for h here, I get 0 on top and 0 on the bottom. So we're going to have to do something different, and definitely different than the previous 2 problems. What do we think we could do here? So square the top and square the bottom. That's a good, so if you have an equation, you can square both sides, but if you have like 2 over 3 and you square the top and bottom 4/9, that's not the same thing. So you can't square both the top and bottom. Good guess though. Try to stay focused. There we go. Any other suggestions? We could multiply the top and bottom by the conjugate. So the conjugate of the top, since that's a minus, it'll be plus. So we have to do the same with the bottom. So I'll give you a second to try that, or a couple minutes to try that. It should clean things up on the top quite a bit. The bottom, you can leave it as h times the square root of 3 plus h plus the square root of 3. That's what the bottom is already. Don't distribute it, just leave it in factored form. Try to clean up the top and see what you can do. Alright, so foiling the top, I have square root of 3 plus h times square root of 3 plus h, which is 3 plus h, plus square root of 3 times the square root of 3 plus h, minus square root of 3 are going to disappear, and then it's just going to be minus square root of 3 times square root of 3, so minus 3. So it cleans up pretty nicely, especially after we can get rid of those 3's. So now I have h on top, and I've got a lonely h on the bottom. Gone. 1 on top. I have 1 on top, and I have the square root of 3 plus h plus the square root of 3. And one more thing to do. We have to send h to 0. So I have 1 over square root of 3 plus the square root of 3, which is 2 square roots of 3. How many got that? All right, not that many yet. All right, so what we have just done with all 3 of these, they're kind of in the same format. I've got like an x plus h there and then just an x there. I've got an x plus h there and just an x there. This I don't have an x, but I have a 3 plus h here and a function in terms of 3 there. Those are all similar. Those are called difference quotients. So a difference quotient is always defined to be f of x plus h minus f of x over h as h goes to 0. That is a difference quotient. It also gives you a derivative. So if you ask a calculus student at the end of the year, if there's one word to summarize calculus, like what's calculus derived or what does it have to do with, they would probably say derivative. That's how important a derivative. This is a derivative right here. And you can always find the derivative by finding f of x plus h minus f of x over h. Okay? A difference quotient is just like difference, meaning subtracting, and then dividing. So that's like the math technique used, and the result is a derivative. And I'll talk more about a derivative here in a little bit. But we're going to try to find a difference quotient. Call this number 4, I guess, if I can get these papers first. So find the derivative, I guess. So f of x plus h minus f of x over h as h goes to 0. We're finding the derivative. So let's say our function is 2x squared. Okay, so if my function is 2x squared and I ask you to find f of 3, what would my answer be?
36.
No, you got to square first. 18. Yep, so f of 3 is 18 because you plug 3 in right there, you square it, multiply by 2. What if I ask you to find f of a? What would my answer be? What's f of a? 2a squared. What if it's f of heart? 2 heart squared. What is f of broccoli? 2 broccoli squared. What if it is f of x plus h? Good. 2x plus h squared. So in the difference quotient, you're going to have to find f of x plus h. So you take your x plus h and you put it in for your variable x. So the first part is going to be 2x plus h squared, because I put x plus h right there, so it's 2x plus h squared, minus f of x. Well, what's f of x? 2x squared over h. And as h goes, just doing, you just didn't know that that's what I was doing. So you're going to be given an equation, and then you have to put that equation in this form, and then you have to evaluate the limit. So I'll give you a couple minutes to find the limit, which is the derivative of 2x squared. Go ahead and try to find that. Alright, so just doing some algebra, I expanded it. Now I can combine like terms. I have a 2x squared minus 2x squared. I can pull out an h on top and divide those off. And h goes to 0, so I end up with 4x. Okay? So what did we just find? We found the derivative of 2x squared is 4x. Alright, so I'm just going to talk a little bit about what a derivative is. Hopefully I'll keep it really simple. So the graph is y equals 2x squared. That's what it looks like. And if I wanted to know what the slope is at any point of a parabola, up until this point you think slope is always going to be a straight line, but every function has a slope potentially. So right here, if I wanted to know at 1, let's say that's at 1, what is the slope of that parabola? We could look at it and we could draw this little slope, like that's how steep it is at that point. At that one point, this is how steep it is. Well, how steep is it? This derivative will tell us the slope of that parabola, the 2x squared, anywhere we want. So if we want to know how steep is it at 1, we could plug 1 into our equation or our expression here. 4 times 1, we get 4. This right here has a steepness of 4 over 1. That's how steep the parabola is at 1. If I wanted to know how steep it is at negative 2, I could plug in negative 2 into my derivative. It would be 4 times negative 2 or negative 8. This has a steepness of negative 8. Notice it's going down. Negative 8 at that point. What is the derivative at 0? In, I get 0 for a slope. Does that make sense? At 0, how steep is it? Is it positive or negative? It's neither. It's flat. So it has a derivative of 0 at 0, which makes sense. So the derivative will give me the slope of the curve at any point you want. You just have to plug it in. So that's what a derivative. We're going to talk quite a bit more about a derivative. Let's do, is that number 4? Let me see if you can at least set one up. We'll call this number 5. Find derivative. Remember, f of x plus h minus f of x over h as h goes to 0. See if you can find the derivative of 6x minus 2. Who's got an answer? Anybody want to try to guess? 6? I would agree with that. We'll verify here. So 6x plus h minus 2 minus that stuff. Remember to put it in parentheses. So that's the f of x plus h. That's the f of x. You subtract them. And then you can just clean it up. So I get 6x plus 6h minus 2 minus 6x plus 2. And I end up with 6h over h, which is 6. All right, so derivative and slope are literally the same thing. They're pretty interchangeable. So if I asked you to find the slope of this at 3, if we put 3 into this result, what are we going to get? 6. What if I put 10 into this result? There's no input. There is no x, which makes sense. Why? Why does the slope never change? Because it's linear, right? It's an algebra question. If I asked you in 9th grade, what's the slope of that line, you'd say 6. We somehow proved it with a bunch of calculus to say something we already knew. The slope of that is 6. No matter what, there's no x in it. It's always going to be 6. Questions?